Good morning, my viewers all over the world. Today we'll be looking at sectors of a circle. This is a continuation of the area and circumference of a circle, which we've looked at in the previous sessions. So today we'll be looking at sectors of a circle. So we need to understand what sectors are. You can see this is the center of the circle. This is a radius, and this also is a radius. So we say two radii, that's the plural form of radius. This is the singular form. So what we mean is two radii would divide a circle into the minor sector and the major sector. Remember, this line here from the center of the circle is a radius, and from here is also a radius. Two radii, singular form, radius, the two of it divides the circle into a minor sector and a major sector. You can see it here, minor sector and major sector. And this distance from this edge to this edge is known as the arc. That's the arc length. Therefore, the area of the sector, you can see this is the formula where our x is 36x divided by 360 degree times pi r square. So you can see this is also derived from the formula for the area of a cycle. Pi r square is the area of a cycle. Then to find the area of sector, that will be combined with x over 360 times pi r squared. Also, the arc length, you can see the arc length. This is the formula for the arc length. The arc length says x over 360 times 2 pi r. So if you notice, this is the circumference, the formula for circumference or perimeter of a cycle, which is 2 pi r. You can see it. This is a radius, also the radius. This is your x. Your x value will become the degree that's given. Yeah, your x value will always be the degree that is given. So we'll appreciate this more once we look at the class activity. So let's move to the next slide to check what the class activities will look like. Now let's look at these questions. So for time's sake, we'll be looking at this. This is the area of show the sector of a cycle. So we need to work out the area of the sector. We can see this is the area of the sector, and we'll be looking at the arc length of this and this. So I will encourage my learners or viewers to have a go at number 2 and this one and number 4 while we attempt questions 1 and 3. Remember, look at the question. So work out the area of the sector. So to work out the area of the sector, we'll say your formula will become x over 360, x over 360 times pi r square, where the value of our x is 80 degree is given here. So that's 80 degree divided by 360. 80 degree divided by 360 times Then we'll take the value of our pi. The value of our pi is 3.14 or 142, but I'm settling for 3.14 times our radius is 7 squared. So we can put this over 1 over 1. Remember, this is not 72, but rather 7 squared. Let me write it properly. Seven squared. Okay, that's better now. Then let's simplify this. This is 80 over 360 times 3.14 over 1 times 7 squared is the same thing as 7 times 7. That is 49. In a nutshell, if you put all this, definitely this is a calculator question. Once you impute 80 times 3.14 times 49, whatever you get, you divide it by 360. So we arrived at 34.1911. But the question says give your answer to two decimal places. So you count after the decimal point, you count two decimal places. This one, two. You look at, okay, this is you count one, two. Then you look at the next available number. The rule says if it's between 0 to 4, you round down. But if the number is between 5 to 9, you round up. So in this case, this is 1, it falls here. So because it's 1 and it falls between 0 to 4, we round down. So we are settling for 34.19 centimeters square. We look at the next one, the length of the arc. So the arc length, the formula says x over 360 times 2 pi r times 2 pi r. So when the value of our x is what? 90. Question, how do we get 90? You can see the symbol. This symbol is a 90-degree. So that's why we are choosing 90 over 360 times. Remember, listen to the question, work out the length of the arc, give your answer in terms of pi. So because we are told to give our answer in terms of pi, so we need to maintain pi. We are not given the figure of value for pi. We'll be maintaining pi. So you can always put this over 1 times radius. Our radius here should be 6 over 1. You can divide straight manually. So 90 here 1, 90 and 360 should give us 4. 2 here 1, 2 here 2, 2 here 1, 2 in 6 should be 3. At the end of the day, we are left with pi times 3. Our answer becomes 3 pi. Question, Why are we maintaining 3 pi? Because the question states we should give our answer in terms of pi. So that's why we are not giving value for our pi. Your final answer becomes 3 pi. The next question is work out the perimeter of the quarter cycle. Give your answer in terms of pi. Work out the perimeter. Remember from the previous sessions, we've said perimeter means the total distance around the shape. So we've gotten the length of our pi, and if you notice the total distance around the shape, this is the perimeter. Since we've known the length of our arc, which is 3 pi, that's 3 pi plus 6, which is the radius, plus, if you notice, this is another radius, and this is like the center of the cycle. This length will be same with this, so plus 6. At the end of the day, once you add up, will be 3 pi plus 6 plus 6. You add up this, so your final answer becomes 3 pi plus 12. Let's check the next slide and cross-check our answers on the answer slide. This is correct. This is correct. This is correct. The only difference, if you note, our answer is 34.19 and this is 0.21. So the reason being that this was used, the calculator was used to give us this. But if you watch as we used it manually, we're doing it step by step and we use that manually because we gave a value for our pi, which is 3.14. But the entire numbers were used calculator. The entire numbers were imputed on a calculator, and as such, the author of these came out with this answer. But if you watch on our own solution, we gave the value for pi, which is 3.14. Therefore, that can explain the difference between the minor differences in the decimal numbers. Overall, the answer is still correct. So thank you very much. I implore my viewers or learners to have a go on the other side. I've given us the formula for both the area of a sector and the arc length. So have a go, then come to the answer session to cross-check your answer. Please do that honestly. By so doing, you will be deepening your knowledge on area of a sector. Thank you very much and thank you. Do well to practice more as we approach the exams in May. Do well to practice more. Ask questions. You can drop your questions on my comment section and I'll be more than glad to help out. Thank you very much. See you in the next session. Bye.